We want to use a derivative of the function to determine the open intervals in which the function is increasing or decreasing, and any relative extrema and the x values at which they occur. So f of x is given to be negative 5 halves x squared minus 10x plus 4. We want to find the derivative, so the derivative will just be negative 5x minus 10. So in order to see where the function is increasing or decreasing, we need to find the critical values. So for the critical values, we set the derivative equal to 0. So in other words, negative 5x minus 10 is equal to 0. I can factor out a negative 5 to get x plus 2. And so x plus 2 has to be 0, which means x is negative 2. Okay, so this is the critical point for part A. Now for part B. We want to see where it's increasing or decreasing. So this is a quadratic. So it turns out it's actually a lot easier if you don't use calculus. But if you obviously have to use calculus to figure this out. But in general, you know that the maximum here occurs at opposite of b over 2a, b being negative 10, a being negative 5 halves. So when you take opposite of negative 10 over 2 times negative 5 halves, you should get negative 2. Okay, so in other words, x equals negative 2 is the peak here, and that's the critical point where the derivative is 0. Okay. So that was a good way to check part A, by the way. Now for part B, we want to see where it's increasing and decreasing. So we know that it's going to look like an upside down parabola because the negative 5 halves is negative, so it means it's opening down. So you would expect it to be increasing from the left, decreasing from the right. But let's verify that using the first derivative test. So if I pick a number less than negative 2, I don't know, let's say negative 5, plug it into the derivative. So the derivative we said was negative 5x minus 10. So I plug in negative 5, I get, let's see, negative 5 times negative 5 minus 10. Well, that's clearly 15. That's positive, right? So the derivative is positive. If I pick a number to the right of negative 2, let's say 0, if I plug in f prime of 0, I get negative 5 times 0 minus 10, and that's negative. Okay, so the derivative is negative. Now, what does that mean about being increasing and decreasing? Well, if the derivative is positive, it's increasing. If the derivative is negative, it's decreasing. So to the left of negative 2, it's increasing. So we'll just say from negative infinity to negative 2. You have to be careful to say that you do not want to include any of the endpoints because the derivative at negative 2 is 0. And then from the right of negative 2, we see the derivative is negative. So again, do not include negative 2 and go from negative 2 to infinity. Okay, now we want to record the relative maximum minimum and where they occur. So it is obvious from the graph above here that this is a maximum. It's an upside down parabola. Well, how do we know it's a maximum? If you look at the derivative, well, there's actually a couple ways to look at it. From the number line, we know that if the derivative changes sign from positive to negative, then you have a local maximum, a relative maximum. So this is arguing using the first derivative. What if we use a second derivative test? So for the second derivative, the second derivative is negative 5, right? So if I plug in my critical point of negative 2, I still get negative 5 because the second derivative is always equal to negative 5, no matter what you plug in. And so when the second derivative is negative, that means you have a relative max. And notice there is nothing else. There's no minimum, nothing, just a maximum. So the maximum occurs at x equals -2. So this occurs at the x value, right, -2. And in order to get what the actual maximum is, you need to plug it back into the original equation. So the original equation we were given was -5/2 x squared minus 10x plus 4. And so here, let's plug it in. So I plug in -2. Get -5/2 multiplied by -2 squared minus 10 times -2 plus 4. So -2 squared is 4 times -5/2 is -10. -10 times -2 is 20 plus 4 is 14. So the maximum is 14. Plug it in over here. Okay, so the relative maximum is 14. And so this completes the problem.